Thanks for inviting me. As I said, that I just came from US, and my name is Mesut. As you know, yeah, that means happy in Arabic. So I was born in Istanbul and spent some years in Belgium, and now I'm currently living in US. So this is the title that I put into presentation: Distributed Caching in Containerized World for DevOps Teams. So we had lots of whys this morning in the keynote, and why I am presenting this is actually matching with the slogan of the DevOpsDays 2019: Unleash High Performance. So that's the main reason. I think you had a very good lunch, and yeah, I'm gonna go a bit technical presentation, so don't fall asleep. Yeah. So this is me, and I'm working for Hazelcast as a lead engineer. I'm in open source, cloud, and Java mainly business ecosystem. And as I explained that, yeah, I lived in Turkey, Belgium some years, and I'm living in US. So this is my Twitter handle. So feel free to follow up over there, and then you can just directly send me messages if you have any questions, etc. Just don't hesitate. So the agenda of today is I'm gonna go first Hazelcast as a company and product, and then I'll talk a bit about caching patterns and how you can deploy these caching patterns when you implement those in microservices into Kubernetes. And I'll go a bit through what options do you have for Kubernetes deployments, and then lastly for day 2 operations. So day 2 operations are, I'm sure DevOps teams are mostly interested, but if you are working as a software engineer and you do DevOps as well, then that's good to learn distributed caching. And but if you are mostly working in production support side or CI/CD pipelines or even SRE, learning distributed caching is important, because nowadays we are mostly developing data-intensive applications. And in data-intensive applications, you put data into your database. That's one thing. And you need to query the data, so you need to have some kind of query language. Or you need to process the data. So stream processing and batch processing is options. But you also need to do some caching if you want to have some performance boost, etc. So that's an important topic, and understanding this is gonna open up some conversations with the software development teams and your DevOps teams, etc. So Hazelcast is an open source company, actually. So those are the products that we have, and those are all open source Apache 2 licensed products, and they are fully hosted on GitHub. Feel free to go and fork and contribute back. Hazelcast IMDG is the one that I'm gonna mostly talk today. Hazelcast Jet is stream processing engine. It's also available as an open source. Hazelcast Cloud is managed version of Hazelcast IMDG, and we have Management Center, which is a management and monitoring dashboard. It is, as I said, Apache 2 license, remote-friendly company. Engineering is in Istanbul mostly, and European countries, so feel free to apply if you are interested. And yeah, we recently raised some money, so yeah, we are always hiring. So distributed caching with Hazelcast. So first we need to check what is distributed cache actually. So cache means you need to have fast access to your data. Normally you have a system of record, your database, etc., and reading from persistent layer or disk, etc., is slow. So you might need some kind of redundancy. Just copy the data to somewhere for fast access. And caching is one of the main options over here. So distributed part is another thing. So previously, in monolith systems, etc., you might have a cache server, and then you just connect to it in your applications. Then that's good. But now it's all about cloud native. Today we heard lots of microservices thing, Kubernetes, containerization, etc. So distributed part is getting very popular and very important. And when you choose a caching solution, it's gonna be in distributed environment. So it should work in distributed environment. So this is basic caching approach. I gave as Hazelcast as an example, but you can apply to any product, any caching product over here. So if you are using Hazelcast, this is open source and free to use. If you are from your application, if you are doing map.get, which means just retrieving some data from cache. If the cache is not inside the cluster, we just go and fetch the data from data store and put, if it's not there, so that means cache miss, and we put into cache, and then your application gets the data afterwards. In the subsequent calls, your application does call again for the same data. It will directly get from the cache, and this is, as I said, for performance improvement. So, okay, this is the previous slide was how Hazelcast work, and I explained read-through cache. Actually, that's the pattern that's called. How can we apply this pattern in Kubernetes environment, which is Kubernetes is, as you know from today's sessions, as container orchestration tool, and how can you use this thing in the Kubernetes environment, and how can you apply? So we see mainly 3 distributed caching patterns in Kubernetes. So one is embedded, where you embed your cache, distributed cache, into your microservices. The second one is very famous Kubernetes SideCar pattern. If you are into Kubernetes, you probably heard about SideCar pattern. And the third one is client server. Client server is also another distributed caching pattern that where you can use in your cloud native deployments. So this is the first diagram that I put. I'll let you check a bit a second, this one, because the other slides are similar. So it's just showing standard Kubernetes environment, where you have a Kubernetes cluster, you have pods, you have microservices, containers inside pods, and when HTTP requests come in, and then it's load balanced to one of the microservices. So in this diagram, as you see, you can embed a cache inside your microservice for fast access to your data. That is very good in terms of simplicity, because normally if you are using a cache as a service or cache server, you need to depend on some other service, right? You need to create a cache cluster or whatever. But this one doesn't need it. It's just embedded inside your microservices, and you can directly use the cache just to improve the performance, for instance. Embedded mode is Java-based, because Hazelcast is written in Java, so you can launch the member inside your Java virtual machine. So if we check it again, so embedded mode is very simple. It's Java only, and data is collocated with microservice JVM. So the third part is something interesting, because not everyone wants to keep their cache data together with microservices Java virtual machine. So maybe that's the disadvantage, that you might not want to use this pattern. but as I said, it's simple. It's good to start with this one. So next one is, as I said, the SideCar pattern that I was talking about, the Kubernetes SideCar pattern. In this pattern, you are not limited to Java, because microservices, as we know, is programming language agnostic, so you can use any programming language you want. So I gave a Python example here. So in this pattern, it's very similar to embedded pattern, but you have two containers inside a Kubernetes pod, which means that you can, for instance, configure each container, their memory limits, CPU limits, etc., independently. So it's not like holding the cache data inside the same Java virtual machine. So you have two different containers here. As the network is local for both containers, so Python microservice can talk to Hazelcast member inside the pod. So this is, again, very similar to embedded mode, but this one is a bit flexible in terms of microservices language that you can use. And again, this one doesn't depend on any external caching system, which makes also it a bit simple. So feel free to try that one too if you are not a Java developer, or if you don't want to implement Java inside your architecture. So in the SideCar, again, it's simple. Those are the programming languages that Hazelcast is supporting. So in SideCar pattern, you can use Node.js, .NET, Python, Golang, even Scala, C++ as well. So those are officially supported programming languages inside inside your Hazelcast client in microservice implementation. The difference here, this one from the embedded, your data is collocated with microservices pod in Kubernetes. This is not in the JVM, but inside the pod. So you have two containers. One is for cache data, and the other one is for your microservice. So this is a fourth. This is another caching pattern that you can see, and this is the most used one by the open source community and Hazelcast customers. You separate the microservices part and your caching cluster part. This is good in the sense for the big corporations, in the sense that you can maintain both systems separately. Maybe responsibilities are different, and your Hazelcast cluster does not have to scale out or scale in together with your microservices architecture. Because in previous distributed caching patterns, your microservice, as they are embedding Hazelcast members, when you grow your replicas, microservices, number of microservices, your Hazelcast cluster member size will also scale out and increase. In this case, even if you have 100 stateless microservices in Spring Boot, you can still keep two-member Hazelcast cluster. And this is simpler for DevOps teams or SREs, etc., who are maintaining the production environments. So small cluster is always better than bigger cluster in terms of manageability. So this is another distributed caching pattern in Kubernetes and cloud-native environments. And this is, as I said, the most used one in production deployments and customers and open source community. So another one very similar to client server architecture is the Hazelcast Cloud. Hazelcast Cloud is a managed service provided by Hazelcast. if you don't want to manage or deploy your Hazelcast cluster yourself, you can just go and subscribe to cloud.hazelcast.com. You create a cache cluster over there. There are some free versions also. And in your microservices, you can directly connect to that cache cluster as a managed service so that you don't have to maintain a cluster. And this is pay-as-you-go model. You can always start, stop, etc. So as long as it's running, it's charging. But normally, this is pay-as-you-go model. Again, this is cache as a service. You can use all the programming language, and it's managed service. So Kubernetes deployment options. This is I explained a bit what is distributed cache, why you need to use it just to improve the performance or unleash high performance in your microservice. And then I just went through some patterns and then how you can apply those patterns into Kubernetes environment. So, but how can you deploy this thing? So Hazelcast has a Helm chart where you can just use Helm install stable Hazelcast. This is, by the way, client-server model. If you are using embedded or SideCar pattern, it's already embedded into your microservices environment. So it's integrated into your development environment. So it's not a separate thing. So over there, you have to use Hazelcast client and Hazelcast Kubernetes plugin. But if you are going with the client server, you need to install Hazelcast somewhere. And this is how you can install it with the Helm chart. So Helm install stable Hazelcast is one option. The other option is Kubernetes operator. So Kubernetes operator is, Helm is a bit like you need to install Helm client on your laptop or on your machine and issue that command. But with Kubernetes operator, this operation is actually running on Kubernetes side. We extend Kubernetes API and call, if you make a call to Kubernetes API to create a Hazelcast cluster is created automatically in Kubernetes cluster. So those are available in operatorhub.io. And if you are using OpenShift or IBM Cloud Private, Hazelcast is already in the catalog. And you can just go and, using some user interface, you can go and deploy it. And actually, OpenShift and IBM became one company now. Probably they will merge OpenShift and IBM Cloud Private in future. But OpenShift is a commercial distribution from Red Hat. And I think we will see it more and more over time in big corporations or deployment environments. After you deploy, actually before you deploy Hazelcast, you might need to consider some best practices because it's not like you just deploy and it works. You need to configure it based on your requirements. And Hazelcast has lots of options. If you go and check, for instance, Helm chart, it is hosted on GitHub under the Hazelcast organization, our chart repository. You will see the options that you can configure Hazelcast, like eviction policies or CPU memory requirements of each pod. If you wanna change the number of Hazelcast members, etc., etc. There are lots of configurations that you can use. So in one of the deployment best practice is multi-zone deployment. And in multi-zone deployment, you actually deploy Hazelcast cluster members into different availability zones. Okay? And why do you need to deploy Hazelcast into different availability zones? Normally, Hazelcast as a cluster, if that was only one zone, and let's say that you have 6-member Hazelcast cluster, when you put a data into Hazelcast cluster, the primary data is going to be kept in one member. And automatically one backup is created in another member. So when you kill one member of Hazelcast inside your cluster, you will not lose data. That's the, that's the beauty of, and you can increase backup count to up to 6, depending on your requirements. But here in this deployment, if you don't want to lose any data, let's say that let's say that your backup count is 1, but when one availability zone just goes away and just crashes or disappears, Hazelcast has a feature called zone aware. So in this zone aware feature, your primary data is kept only on one availability zone, and the backups of that primary data is in another availability zone. So if my one of the data is on availability zone B, its backup will be in zone A, and the other way around also. If my data is in member 1, for instance, its backup will be on the other availability zone. When availability zone just goes away and disappears, or you have networking issues, etc., then yeah, you are good to go, because you will not lose data. Even if your backup count is 1 and 3 members disappear, the other cluster members will just recover the data. So this is one best practices that you can consider. And the other one is predictable resource allocation. In containerized environments, you need to specify CPU and memory limits. And when you specify CPU and memory limits, this is a bit deep in Kubernetes. But if you don't specify your CPU and memory limits, Kubernetes is all about creating pods and deleting pods, etc. If you don't specify those limits, then Kubernetes scheduler might just kill your pod because it is having some resource issues, etc., and allocate some other pod. So the best practice over there is that you need to configure your CPU and memory limit, and at best, if you can do, they make it same. So for instance, I need 1 virtual CPU and 1 GB memory. Both request and limit configuration must point to the same number. So this is another best practice. And deploy Hazelcast is Helm chart is one of the recommended ways nowadays. So this is you can deploy Hazelcast into Kubernetes cluster with your own deployment configs if you are familiar with the Kubernetes. But if you use Hazelcast Helm chart, it's actually opinionated environment. So it has some default opinions about the configuration. Even if you don't configure some parameters, we just select the best options for you and you just deploy it. So one of them is graceful shutdown. Normally in Hazelcast, it's not by default graceful, but if you enable if you just deploy Hazelcast with the Helm chart, graceful shutdown is enabled. Graceful shutdown is important because in cloud native environments, your pods can shrink based on your scaling algorithm or configuration. Let's say that you have 6 Hazelcast member cluster and you want to go to 3. If you delete 3 at once, then again you can just lose some data. So instead of doing that, you just need to kill the pods one by one and tell Kubernetes that, yeah, Hazelcast is gracefully shut down now, shutdowning the member, so Kubernetes will wait. So this is one thing. The other thing is stateful set over deployment. I think stateful set is a bit better than deployment, but it's not like, yeah, you can configure deployment also in that sense instead of stateful set. We recommend stateful set to deploy it, but you can do the same with deployment. As in my previous presentation, yeah, you need to tune up the resource and requests and limits for some reasons, especially for the Kubernetes scheduler thing. And default health check configuration, if you deploy Hazelcast with the Helm chart, we configure for you the health check environment and endpoints. But if you are deploying yourself with your own configuration, then you need to include health check, because health check is important. That's how Kubernetes understands your pod or containers are healthy. Yeah, and for instance, even if it is not healthy, your pod or container, it can still be running. And there is no way to tell Kubernetes that this pod is not healthy and restart it, because it can be a deadlock inside the container, or there are some other problems that you can see. But if you configure the health check endpoints, which gives an option Kubernetes to call some REST URL to see if the container is healthy or not. So day 2 operations. So far I explained distributed cache and how to deploy it and deployment best practices. But when you deploy it, there are some operations that you need to do over time. So Hazelcast cluster is running, or your distributed caching cluster is running. But after some period of time, you need to do something. So this something, I'll just go with the next slides. So for instance, scaling Hazelcast cluster is one thing that you might need to do, because Hazelcast is distributed cache, and it is masterless design. So whenever you create a new members, it automatically joins to the cluster, and then this data partitioning is done automatically. So there is no master slave. In that sense, it's very elastic and cloud native. And scaling is needed mostly when you see a growth in your cluster. You see a growth of data in your cluster. And you might, in that sense, if your cluster is smaller, then eviction policies will kick in, because you need to delete some data from memory. If you don't do that, then you will get out of memory errors, etc. So scaling in that sense is important. And those are the commands that you need to use. kubectl, scale, or Helm upgrade. Those are the commands that you can use to scale out or scale in Hazelcast cluster. Those commands is actually to scale out, scale in any pod in Kubernetes environment, so it's just something general. But yeah, you can just feel free to play with those. For the scale down, as I mentioned in previous slide, so scaling down needs to be done one by one if your backup count is 1. Because otherwise, if you kill 2 members at the same time, you might lose data. You will lose data, and that's how we tell Kubernetes what to do. If you are using stateful set, it's guaranteed that it's done one by one. If you are using deployment object of Kubernetes, you need to specify rolling update strategy. And the last part is horizontal pod autoscaler. So scaling can be done in 2 ways. One is manual. So if you go with the manual, kubectl scale and Helm upgrade is your tool to do. But if you want to do it auto-scaling, which means that if you see a hike in memory and CPU usage, you can tell Kubernetes that by automatically, for instance, let's say that if the CPU usage more than 80%, just scale out my cluster. And in that sense that you don't have to do anything, Kubernetes automatically will do the scale out. And if it goes down under 80%, then your cluster will be scale in or shrink again to its original size. And that's the beauty of the horizontal pod autoscaler. It's done automatically. The other day 2 operation is rolling update, and rolling update is needed in such cases. So you might want to, this is also not specific to Hazelcast also. Any software you deploy into Kubernetes, you will need to upgrade it at some point of time. And that's one thing. And you might change some configuration and do redeployment also. That's another rolling upgrade and option. And for Hazelcast, you might want to add some class path extensions, putting new jars into class path, etc. This is another reason you might wanna do rolling upgrade. So rolling upgrade is also again important because rolling upgrade means zero time deployment compared to manual update. So if you were before cloud native environments, if you were in a single machine environment, to update software or configuration change, etc., you have to reboot the machine or application itself. But in cloud native environments, especially in Kubernetes, you don't have to do that. So there are some different rolling upgrade mechanism like blue-green deployment, canary deployment, etc. So those are all for, zero downtime purposes. So this is why you're gonna do it, and those are the commands that you can use. Helm upgrade and kubectl set image with your new image is one option to do the rolling upgrade. And again, in your configuration, you need to restart the pods one by one, enable graceful shutdown, and optimize grace period of Kubernetes. The grace period is also interesting. Kubernetes is when it decides to kill a pod, it actually sends a termination signal to the pod. And in Java, for instance, you can write some hooks to get this event and do graceful shutdown thing. But if your shutdown part is too long, Hazelcast will come and check the grace period, and Kubernetes will come and check grace period. If it is longer than that, it's by default 30 seconds, then it will directly kill the pod without waiting you gracefully shut down your pod. So based on your data inside the cluster, etc., you might want to change this one. In Helm chart, we made it 10 minutes, but depending on your architecture, you can use different values for grace period. So this is another day 2 operation, and it's very important in cloud native environments. So Hazelcast has a management center. It is free up to 3 member cluster. So you can use Hazelcast management center to monitor and manage the dashboard. Hazelcast is monitoring and management dashboard, and you can monitor Hazelcast cluster. You also need to configure the metrics. For instance, with Prometheus, you can use some other stuff, but Hazelcast supports Prometheus metrics by default. So if you pass metrics enabled to Helm chart, each Hazelcast pod expose their metrics in Prometheus format. And then you can use horizontal pod autoscaler. You can create Grafana dashboards to see what is happening in your cluster, or you can even use custom metrics API, for instance, if you want to use horizontal pod autoscaler with custom Hazelcast specific metrics. So this monitoring and alerting is another thing. If you see an increase of the memory usage or CPU usage, etc., then alerting is also important. That's something you need to enable. So this is my presentation. It's a bit specific to cloud native, and in cloud native specific to Kubernetes. But I think, yeah, today Docker Swarm also mentioned. but as far as I see, Kubernetes is the clear winner in that game. So it's good to learn Kubernetes and containerized environments, and then afterwards, if you decide to use those, you can use Hazelcast as a distributed cache because it's very natural fit for your deployments, and then you can get some performance improvements. Okay, so that was my last slide, and I'll thank you. Thanks for inviting.